All right, ladies and gentlemen, welcome to today's. This is going to be getting a jump start on tomorrow's. We're going to be looking at all the methods that we have studied today and determining what's going to be our best method, writing the equations sometimes, the systems, and then finally solving. So our objective today is we will determine the best method for solving systems solve the system and write systems sometimes. Okay, so it's not so much vocabulary time, but this is just kind of a recap of all the methods. We've talked a little bit about graphing and when it is best. Graphing is actually best when they give you a graph, okay? If they give you a graph, you should probably look at it. Can anybody tell me, where is it that solutions live on a graph? My chats. Where do solutions live on a graph? How do I know where they're at? So let's say I've got coordinate pair or coordinate plane right there, X and Y. I have two different equations, and solutions live where? All right, good. Where the solutions live is where the lines touch, okay? So just kind of keep that in mind. That might be a little thing if you didn't know and you couldn't answer, I would write that down. Solutions live where the lines touch. All right, substitution. Substitution is when you have something like this, you got like y equals 2x minus 15. And then you have 3x plus 5y equals 10. Substitution is usually best when you have at least one equation. I'll pretend that's a Q, with an isolated variable, a variable all by itself. So for example, right here, you have y all by itself, right? That's a good indication. Hey, that's going to be a good one to substitute. Okay. The one that we've been doing the last couple of days is elimination. And elimination is best. Let's see. Elimination is best. It's kind of one of my favorite ones just because it's kind of like a puzzle to me, but elimination is best when you have opposite terms, or maybe really close to being opposite, right? Okay, so opposite terms kind of means like when you've got something like this, where you have 3x, that opposite pair, right? The zero pair. And then maybe you have something like this. Notice how you have positive and negative, the same coefficient, and you have that, okay? So that zero pair makes this a really nice candidate. Also notice how X and Y are like in the same position. They're both on the same side of the equal sign. Any questions on that? Okay, let's get into this. Cool. So let's determine the best method for solving this particular system of equations, and then we'll do it that way. All right, so in your chat, I'm going to pause this. Okay, so in example 1A, we talked about elimination being the best method because we don't have a variable that's isolated all by itself. So that eliminates substitution. And then usually if we're given a graph, then graphing is going to be the best method. Otherwise, if we're doing it by hand, elimination might be good. Okay, and then we talked about how we're going to get these to be opposite pairs. The idea was that if we could somehow get 2x and then make this negative 2x on the bottom, right? So the top one would stay completely the same. But if I multiply, and we talked about basically, or divide, we could divide by negative 2, divide by negative 2, and divide by negative 2. That 4 divided by negative 2 gives me a negative 2, right? Then I got positive 2 divided by negative 2, which is negative 1y, okay? And I have 34 divided by negative 2, and we're looking at negative 17. Okay. If I'm going too fast or you're not sure about something, let me know, okay? So what this has done has allowed us to create in one step a perfect 0, which we can eliminate. And then we just bring it down like we've been doing for the last few days, where we have 3y minus 1y, 2y, and then you have 23 minus 17, which is 6. And the last step, divide by 2, divide by 2. And I'm going to put my little solution here. So y is going to equal 3, and I'm going to put 3 in the y position. Now I can go back and put it into an equation. So I've got 2x plus, and I actually know what y is. And then we're going to go ahead here, just solve it out. Plus 9 equals 23, minus 9, 2x equals, that zeroes out, and you have 14. Divide by 2, and x will equal 7. Okay, and that is your solution. Questions? All right, so let's look at example 1b. I liked our discussion before. Determine the best method for solving the system of equations and then solve the system. So in this equation, go ahead and tell me in the chat, tell me what method you think would be best. So decided that substitution was best because we already have one variable that's already isolated. So we're just going to go ahead and plug it in. All right, ladies and gentlemen, I'm going to go ahead. This would be a good time to pause. I want you to go ahead and solve for x, please. So when we substitute, we just go ahead and take everything that's y equals, and we put it right in there, yeah? And when we do this, it's very important that we distribute the negative. In essence, that's like -1, right? So that's going to be 5x minus 3x. And then that's going to be -1 times -24. And this is where I'm betting a lot of people made a mistake. And that's positive 24. Okay, so then we combine like terms and we get 2x because 5x minus 3x is 2x. And then we're going to use our additive inverse to move that 24. And so here's our 0 pair. 2x is equal to -16. And then we divide. So when you have different signs, you want the difference. Remember that. We divide by 2, and x is going to equal -8, ladies and gentlemen. Okay, so I'm going to put that right there. All right, let's practice a little bit more. And let's go ahead. Oh, okay. Let's see. Let's go ahead and practice. Go ahead and you can, I personally would recommend putting it into that top equation since y is already by itself. And plug in your value for x, and let's see what we get for y. I would hit. All right, welcome back. So when we plug in, we're just looking at this. Let me go ahead and y is equal to 3 times negative 8 minus 24. So 3 times negative 8, negative 24, minus 24. When you have the same sign, you want to sum. And that is, and you keep the sign you got, 48, negative 48. Any questions on the math? Okay. Great way to double check, especially, yep, it's okay. Good thing like you're practicing now and catching it now. Best way to double check it if you're like on a test is, you know, plug it into either equation and see if you get like a true statement, right? See if it comes out to be true. Okay, let's go ahead and let's look at number 5. Real quick, you can type G for graphing, elimination E, and substitution S. What do you think? What jumps out at you? Yeah, I agree. And for those of you who haven't made up your mind, notice this opposite pair right here, right? All right, good. So I'm going to go ahead here and I'm going to give y'all like about a 2-minute head start on this problem, okay? I'm going to pause. So again, we have our 0 pair. 4 plus 5 is 9. Get 9x. 24 plus 12, 36. Divide by 9, and x is equal to 4. All right, let's do the second part. I'm going to pick, you can pick either one. I'm going to pick 4x plus y equals 24. And I know what x is, so I'm going to plug that in. We have 16 minus 16. Zeroes out. Y is equal to 8. And we're done. Any questions, boys and girls? All right. Let's look at this next one. It's entitled Example 6. What method do you think would be best? If you are thinking in your brain substitution, I would agree with you because x is already by itself. Okay, so ladies and gentlemen, this might be a good time to pause the video if you're watching the video. Go ahead and solve this problem. Okay, when we're doing this, we know what x is, so we're going to put parentheses right there. We're going to drop in what x is equal to. We're going to distribute. 6 times 4 is 24. 6 times negative 2y, negative 12y. Minus, and you could put the 1 there, 1y, it's the same thing, negative 145. These two are like terms. Let's combine them. That's negative 13y equals negative 145. So we're going to subtract 24, and that will zero out. I'm left with negative 13y equals, now I got the same sign, so I'm going to sum. And that's 9, 6, and 1, and I keep the sign that I have. And we divide by negative 13. And correct me if I'm wrong, but I do believe that y would be equal to, that's a positive 13. 169 divided by 13 is 13. Yeah, you got what I got. Cool. So that was my y. Then the x, you know what? Maybe I put it right here underneath it. I'm going to plug in here. X is equal to 4 minus 2y. I'm going to plug in. X is equal to 4 minus 2 times 13. And 2 times 13 is, what, negative 26? Yeah. And then 4 minus negative 26 is negative 22. This is what x is. Good job, Gabriel. So I've got this. I've got this. Let me go ahead and put it in one final shebang. Negative 22 and 13. Good. All right. Let's go ahead, and I think we've hit a good stopping point. Okay. So ladies and gentlemen, if you have any questions, please feel free to ask. Let me go ahead and let's see. And to everybody out in video land, thank you so much for tuning in. I will see you tomorrow. If you are in my Zoom session, you are dismissed unless you have any questions.